Hello and welcome back to the OpShin Pioneer Program. This week we will start with an introduction into UTXOs, eUTXOs, and then getting our hands dirty working on eUTXOs. Specifically looking how validator scripts fit into the context of eUTXOs. So first, we will briefly discuss the difference between on-chain and off-chain components in smart contracts, and then recap the eUTXO model and its key elements: the datum, the redeemer, and the context. These concepts are independent of any language, so if you want to have more in-depth explanations, feel free to check out this section of the OpShin Pioneer Program, which gives also an introduction into these concepts and maybe helps you with providing a different perspective. Finally, we look at how data is represented in OpShin programs, because contracts operate on complex data types and it's not entirely straightforward on how this maps. Finally, we present a very simple validation script, and it's called gift.py, and then walk you through how to interact with it. So, smart contracts on Cardano consists of two main components. One part is on-chain code. This involves the validation script that determines whether a transaction can be executed or not. So this is basically this is the real smart contract. This is what's run by the Cardano node to verify that you can spend funds from an address, that you can mint a specific token, that you can withdraw funds from a script address, and so on. And then there's off-chain code, which is run on your computer, on your device, where you fetch data from the blockchain and construct a transaction, then submit it to the blockchain. And after the submission, again, the on-chain code is executed by the node to verify that the transaction is valid, but locally you run everything, you prepare everything, you check how the transaction should look like. But ultimately you need both parts really to interact with the smart contracts, because the smart contract itself does not ever do anything on its own. You always need an off-chain component that creates this transaction and interacts with the smart contract. Okay, so for the extended UTXO model, recall that compared to the standard UTXO model of Bitcoin, the Cardano extended UTXO model introduces script addresses alongside traditional public key addresses. So in Bitcoin, you have payment addresses which are controlled by secret keys, cryptographic secret keys. And in Cardano, this is a secret that a person knows, for example, or that's stored like on a device, and you can sign any transaction with this secret. But on Cardano, you can also have script addresses, and these script addresses are they are smart contracts. So actually, when you try to spend funds from this address, from script address, then instead of requiring a signature from a specific person, what's happening on chain is that the node knows, okay, for this address there is a specific contract, and this a program that I will run, and if the program runs and passes, then I can spend the transaction. So how should this contract be run? There are three. It's basically a function that takes three parameters, and these three parameters are the datum, the redeemer, and the script context. The datum is some auxiliary extra information that when you send funds to an address, to the script address, you attach the datum, or you can think of it as a state. I send funds to an address and I initialize it with a specific state saying, okay, these funds are supposed to go to this person, or they are supposed to be spent not before a specific deadline is reached. So they attach some extra information. You have the contract that controls the spending, and then you have some extra information that's attached to every single output to this contract. And now these are sitting at the script address waiting to be spent. And when you try to spend them as a user, you take this output with the datum and you say, I want to spend it in a specific way. This is the second argument. This is the redeemer. The redeemer, or maybe like an action, I can say, okay, I want to spend these funds because a user on a DEX canceled their transaction, so I want to withdraw the funds. Or I want to fill, thinking about a decentralized exchange, you want to swap your tokens. So you can either try to spend the funds to withdraw, to return the funds to the user without any swapping, or you can exchange them by providing the tokens that were requested originally. So in order to tell the contract how this transaction that we're building is intending to use the output, this is what we're doing in the redeemer, in the action. We say, okay, now I'm trying to spend this in a way that will correctly return the tokens, or that will fill the intent, or something like this. Or for tokens, oh, I want to mint this token, or I want to burn this token. It can be different ways to interact with a script, and this we tell the contract how we intend to interact using the redeemer. Now finally, the script context is the third argument. The script context provides the contract with some high-level information about how the transaction that we have built and where the contract is invoked is built. So it provides all the information about the transaction that's available. This is all the inputs, all the outputs. There is which other smart contracts are spent. There's information about when does the transaction happen, like is there in which time frame, who signed the transaction, all these kinds of things. And this data is constructed by the node and passed into the contract. Passed into the contract when you try to operate. So this is the three arguments. One is the current state, the datum of the UTXO. Then there's the redeemer, the user trying to spend the funds, telling the UTXO how it's intending to spend the funds. And then there's the script context with some metadata about the transaction that you have currently built. And all of these together are then processed by the smart contract, and the smart contract tries to make sense of this and either fails or passes if the transaction is then valid. So we will now do a hands-on part where we look at really the code itself, and then we will maybe get a bit better feeling for how this data behaves, how these parameters are created. Okay, now let's dive into a concrete example for a smart contract. I'm using the Integrated Development Environment IDE PyCharm. Just clear this. It's the community version is free, and I find it quite convenient. But also tools like Visual Studio Code are good ways to look at the data. So you want to have a tool that supports Python, so that you get some features like syntax highlighting or reference resolution. So this is the gift contract. Maybe to start, the basic structure of these contracts is always you have, or you usually want to start with importing everything from the OpShin prelude. It's nothing fancy. This is really just also a list of definitions and functions. This is already valid OpShin code, and you do not have to import it, but it just gives you most of the convenient things in context. And then the crucial part is that you define a validator, which is just a function that takes exactly these three arguments that we talked about: the datum, the redeemer, and the context, or if you will, the state and the action and the context. So if you this is now a really raw low-level contract. You will usually not write contracts like this, and what's unusual here is that we use built-in data to define the type. So if you look at the definition of built-in data, it's anything, and anything is just like really it could be a dictionary, int, bytes, whatever, and this is defined in the low-level types of PyCardano. So the reason I demonstrate this here is to show you how like deep down the validator function is really nothing else but a function that takes 3 arguments of any type. It doesn't really know which type these are. These are just built-in data, and then we can deconstruct this data by looking at how it's composed. Is it an integer? Is it bytes? Is it and that's now the interesting part for these Plutus data. They have constructor IDs and they have fields, and then we can distinguish them based on the constructor ID and the fields, can analyze, can access fields, can handle them mostly like Python objects. But really, just to give you some context, on the lowest level, we don't know anything about the data. Still, yeah. What does this contract do? It takes the 3 arguments and then it returns none. So it doesn't return anything, and this essentially just means it will always pass, right? As long as it doesn't throw an error, it will pass, and there's nothing here that can really throw an error, because returning always succeeds, and parsing the arguments without any structure doesn't really mean anything. So yeah, there's nothing happening here. Still, we can have a look. I will navigate here. We go to Python 3 scripts build. Okay, I need to initialize the end file. I will just put in some random data here. Okay, let me see. Just copy this env. And here we had our preview link. So now try to build the scripts, and now we'll find an assets folder one level above the lecture. I'm currently in source week 2, and this is lecture /gift, and now we have here assets gift, and this also some other contracts, but this is the main thing. You can find the blueprint, where we see that really there's nothing interesting here. Then there are smart contract addresses. This is the whole CBOR. It's very short because there's nothing happening here. This is a version of the CBOR that you can pass into the Cardano node, and this is the policy ID. So yeah, that's the basic thing to build a contract, and this contract really doesn't do anything. Yeah, it ignores the datum, it ignores the redeemer. This is why it's highlighted gray here, because it's not used. Then returns none. Right. Now what I've done running this build command is essentially the first step in deploying this contract on chain. What the build script does internally is it runs OpShin build spending and then lecture gift.py. This will actually fail, so put any. If you put spending as an argument, it will do some extra checks to make sure you didn't accidentally have the wrong types or mismatching arguments. But if you put any, you are allowed to build anything. And now with the normal argument, things are built into build, and then you can see the same as before, same CBOR and so on. Okay, so outside of the Pioneer program, you will not have this build script that I used before that compiles into assets something. You will usually use this OpShin build command, and that's why I'm just demonstrating it here. And again, here you have like Bluetooth, Pelosi ID, and if you look at any other smart contract introduction, you will find that these files are very useful for knowing how to deploy. Okay, this was already the first step. We have a very simple validator. You now know how to write the most basic one that always passes, does nothing, and how to compile it. Try running these commands yourself. See if you run into any issues, and yeah, see you in the next lecture.